Hello, today we will be discussing Lecture 3. The topics covered are accelerometer measurements and EMG measurements. The materials used today are going to be the EMG sensor, a breadboard, a microbit, a dragon tail breakout board, a USB to micro USB, electrodes, and some connectors for the EMG sensor. If the microbit extension board is not connected, well, let's put that in your breadboard. I usually put the top pin in the first hole of the breadboard. Make sure that it says number 1 on the left side of your breadboard so it is consistent across the classroom. Then let's insert the microbit into the breakout board face up so you can see the microbit logo with the top of the breadboard. Finally, let's connect the micro USB cable into the microbit. The USB component will be connected to your laptop or computer. It is convenient to put a wire connecting the breadboard ground to the microbit ground in the breakout board. Usually the ground is denoted by the blue line that runs across the breadboard. This will be useful in the future to connect all the ground connections into the breadboard with more space. Well, let's start our MakeCode script. First, we go into the LED function and use plot bar graph off. This will help us visualize what data we are measuring. Then, we go for the acceleration input and select Z. Finally, we change the up to value to 1023. Now we can download the code into our microbit. If the microbit has not been paired, use the pair now function. Make sure your microbit is connected and hit next until you get what we're seeing in the screen. Select the paired microbit, hit connect, and then you should be done. Now, every time you download your code, it will automatically upload into the microbit, and it will also let you see the data live. We see that Show Data Device has appeared below Show Data Simulator. The data being plotted right now is due to the functions of plot bar graph off and the data from the acceleration measurement. Now let's change the axis of acceleration from Z to X. Now let's download the code once again and plot the data using the Show Data Device. We can see that while the microbit is facing upwards, we have an acceleration of 112. But as we move it side to side, it increases plus minus about 1,200. This is because the angle at which gravity is affecting the accelerometer is changing. If we change the axis back to Z and we plot the data, we see that the measurement starts at negative 1,000. This is because gravity is aligned to the Z-axis, which is right into the microbit. Previously, the direction of the X-axis was side to side to the microbit. So now, if we oscillate the microbit upwards and downwards, we can see a spike in the acceleration measurement. Think what would happen if you oscillate the microbit side to side. Is the amplitude the same? How about if you change the axis of acceleration to X instead of Z? How does it compare? Now we're going to try our EMG measurement. So we take the black cable, that's going to be our ground, and we can connect that on the breadboard or on the breakout board. Next, the white cable is going to be our signal cable. We will connect this in pin 3. Now we can use the EMG electrode extension cable. The aux cable will be connected on the EMG. Make sure it is connected all the way through. No need to push too hard. Then we're going to get our sticky electrodes and connect one on each electrode connector. So one for the yellow, one for the red, and one for the green. Don't remove the film covering the sticky side just yet. Do that when you're about to connect it to your arm. So in this case, I'm ready. You're going to connect the red cable and the green cable across your bicep muscle. These are going to measure a voltage differential across your arm. Finally, connect the yellow electrode far from your bicep. This should work as a reference point for the voltage across the red and green. Now, let's create a new code. We will name it EMG muscle mapping. If you load the page and you see the microbit in the display jumping back and forth, just refresh the page and that should be gone. So now we will go to variables and we will create a variable named EMG. It is crucial that EMG is all in lowercase. This is because some of the hidden functions that we will be using today use the variable EMG in uppercase. Now let's drag the set variable EMG2 and put that into the forever loop. Now let's add a plot bar graph of, and then we're going to add an extension. You can copy and paste the extension or write it down yourself. This extension is useful because it has tools to clean the EMG signal automatically. If this weren't used, it would be really hard to interpret what the muscle voltage means. Now that we included the extension, let's go to Custom, pick EMG Filtered, and drag that to Set EMG2. Then also drag the variable EMG into Plot Bar Graph Of and change the up to value to 1023. So now let's download the code, and you will see both the EMG muscle signal and my arm. So as I flex my muscles, we can see that the EMG voltage increases, and when I relax them, it decreases. I can also hold the contracted position to keep a high signal. However, please be aware of your surroundings. Since the voltage in the surface of our screen is very low voltage, electrical systems around us can interfere with the measurement signal and give us a wrong measurement. You should move the microbit and the EMG away from potential electrical noise sources. In the example video, we can see that as we approach the potential electrical noise source, the baseline voltage increases from 120 to 240. Thank you for listening, and until next time.